Today I will announce the discovery of new mathematics for advanced information technology. When I say new mathematics, I mean a set of mathematical rules that have been there but not exploited yet by the human mind. And all this comes about because of just one idea. And the idea is very simple. Everyone can understand it because I myself started developing this idea when I was just 5 years old. And I hope that all of you can unite with me to understand what I'm going to explain. There is nothing hard here because everything you are going to listen is very practical. It is something you live with, but you don't understand. And it's all about numbers. So the discovery started with this idea. If you have a number like 7, as we used to think, 7 is just a 7. But the idea is that inside this 7 there is 6, there is 5, 4, 3, 2, 1. So you have something like this. Inside 7, you will have all the values here. Therefore, the number 7 looks like this antenna. This antenna. As I will show you, the antenna has segments. It can be stretched and we can reduce it to one piece like that. When you look at it as one piece, you may say this is just one, but it is not, because inside are other segments which are smaller, and they range from the bigger one to the smaller one. Therefore, when you pull out the antenna, you see what you get? It's the same. So inside 7, there is 6, 5, 4, 3, 2, 1. That's why number 7 can express itself using all the values below it. And when I say the values below it, you see this. It's just like that. Inside 7, there is 6, there is 5, there is 4, 3, 2, 1. In order for you to understand this idea, I would like to give you an example of money that everybody likes. If you have, for example, $100 bill, you go to a store, you buy an item for $12, then you will be given a change. The change will be $88. And this change will come to you in bills of 50, 20, 10, 5, 2, $1. All this, as you see, come from just this one bill of 100. So 100 can produce as many bills as possible. If you change this money into bills of $1 each, then you will have a long line of bills of dollars. And also, if we can have the license to make the bills we like, we can make bills of 99, 97, 84, 73, bills of 26, bills of 9, and down to 1. So we will have all these possibilities we call degrees of freedom. But in our terms here, going back to the first graphic here, it shows these are levels of variability. So if we go back to our number 7, all these values mentioned here are the levels of variability of number 7. 7 can use all these values to express itself. And as a consequence of all of that, numbers can produce energy at different levels. In order to do so, we have to stretch them. We can stretch them in 1 dimension, 2 dimension, 3 dimensions. This is what we get when we stretch number 7 in 1 dimension. We have these values coming out of number 7. When we stretch it in 2 dimensions, look at what we get. It's huge. Every little square here or cell represents a location which will have a value of 7. So there will be different values. That's why you see, like here in 2 dimensions, so many values this way. And if we do it in 3 dimensions, look at what we get. But unfortunately, I was not able to make the one of 7. This cube you see here is just from number 4. This is number 4. Therefore, we have 1, 2, 3, 4 levels. If we have to do it for number 7, we will go 3 more levels. And if we consider, as we said here, that every little cube represents a location for number 4, so how many cubes we have, little cubes? So many. We have so many little cubes. And this is a tremendous power, a tremendous energy.